It's 12 past 2 at ALL4PACK TV, and we're going to have a discussion on packaging for today and tomorrow. Active, intelligent, connected, ultra-smart. How far can we go? Lots of R&D going into the topic for years and years. Where do we stand today? To discuss this today, we have Linda MONBORREN. You're the founder of Smart Impact Consulting, and you're a professor of international trade. Then we have Abdellah, you're a full professor in the Department of Chemical Engineering at Polytechnique in Montreal. Opposite you, Gilles, LENON, you are the chair of the CTP Technical Center for Paper and director of TECHPAP, specialized in specialized materials. Then Hervé OLLIEN from Samsung Electronics. We're familiar with Samsung. It's a small company, right? And you're the head of the Home Appliance Division. So welcome one and all. No, Linda MONBORREN, we're going to begin with you, because we first have to define the topic, which is a very vast field. You wrote a doctoral dissertation on the market for smart packaging. And in French, we use the term smart packaging. So in English, it's simply smart. In French, we talk about active, intelligent, and connected. Could you discuss what smart packaging is? Well, smart packaging is broken down into two parts, intelligent packaging and active packaging. It's like those who think and those who act. Well, we have intelligent packaging, which provides information, and active packaging works with the product. Let's discuss active packaging. Well, this covers a broad range of technologies. Absorbers, oxygen absorbers, ethylene absorbers. There are lots of things we can do. Also, packaging which releases things. Yes, releasing packaging. Yes, instead of absorbing something, where it's going to be released into the food or space. So what types of substances could this be? CO2 or oxygen or ethanol? Lots of things are possible. And then you have self-heating or self-cooling packaging. There are lots of types of packaging. Antimicrobial packaging, and this could be included with antioxidizers or antifungus things. And then you have edible packaging. Yeah. Okay, these are packages which can be eaten. That's right. Yes, there are packages which are intended to be eaten. Is that a fine end to the packaging life cycle? Well, yes, but initially, there is a problem, however. Initially, the package has to protect the product, but any edible package has to be packaged itself in order to protect it. No. So we have active packages which act on the content. So we see this in food packaging. Well, yes, I focused my research on food and pharmaceutical packaging. Now, this covers a broad range. There are lots of regulatory constraints regarding active packaging. So we won't be able to deal with all the topics in just a few minutes. Well, very simply, because we don't know what is used to package our foods. What types of packages are already available? Well, here we have to make a distinction between Europe, which has very little in the way of active packaging, because legislation on active packaging was simply enacted in 2010, and this is an impediment to broader dissemination of the technology. Well, we haven't gone very far, said the journalist. No, we haven't gone anywhere. We still haven't managed to get off the ground. We see bans on imports of foreign products. In the U.S., a lot is available, and you can't import it here. And there are some small companies in France. There's one company. In Europe, there's only one company which provides oxygen absorbers, but it's a very small-scale business so far. Now, what are some of the obstacles? You said that regulations are recent and constraining. Are there consumer impediments? Well, you have problems at every level. You've got government regulations first. Let me point out that Europe is the only part of the world where there is a specific regulation for active packaging. In the rest of the world, active packages are just packages like other packages and subject to the same rules. Another problem is cost. They're relatively high for some technologies. I think we'll discuss this with germ protection. The costs are pretty high. And then we have existing technologies which tend to involve modified atmosphere packaging, with which we are familiar with. So there's resistance to change. Manufacturers aren't ready to change their lines and processes, and consumers aren't ready to accept the presence of additional things in contact with their food. So, and there's also the fact that expiry dates are extended, but this could be counterproductive because consumers might be afraid of that type of thing. So this means you could sell meat that would be edible for 6 months. Yeah, I think consumers might be afraid of this. So, Abdellah, you're a professor in the Chemical Engineering Department in Montreal Polytech. Do you agree with the distinction between the two types of packages, active and intelligent? Well, active packaging interacts with the food, but it's not necessarily going to it won't necessarily provide any additional information for consumers, whereas smart packaging will not necessarily have an action on the food, but which will provide information to the consumer or to the final user or place of use. So I think this fits in pretty well with the definition the previous speaker gave. Now, you work on both categories, I guess, active and smart or intelligent packages. We've seen some of the impediments to broader dissemination. Do you think that's correct? And do you think we can have broader dissemination? Well, there are some areas where things are changing. Absorbers in general and oxygen absorbers, things are moving forward. Well, I'm familiar with North America, and especially oxygen absorbers. Well, in the United States, you have that. Well, in the U.S. and Canada, these are little bags which are included in the packaged food, or directly in the film used to package. So you can either separate them or include them in the film. And okay, this is common in Canada and the U.S. For dried foods, nuts. For instance, where oxygen can be a problem, or swiftly perishable goods. This is another area where applications are developing quickly. What about CO2 releasers? They are used. I'm less familiar with them. Now, you're specialized in the in Montreal Polytech. Now you're working on nanostructures and nanocomposites using an electronic system or electronic knitting. So I understand that using chitosans, which are the structures of microcrustaceans. Could you discuss all that? Well, shrimps and crabs, crustaceans, have a carapace with keratin and with chitin, and when you recover the chitin, after deacidulation, okay, that's a process to. Okay, you have a number of chemical chains that you're going to incorporate in the process. Okay, that's structure simplify it. Imagine that you're going to change the chemical structure to add other things which are going to provide different characteristics, antibacterial or other features. And this is used to develop antibacteria treatments. And for electrical knitting, okay, this is used to make nanofibers. So we have a solution with a polymer, a material, like a chitosan. It's subjected to an electrical charge field, and you're going to have filaments. And what do you do with well, it can be like paper that can be used under meat, for instance, to prevent deterioration, or you could use it to coat a product by induction, or you can simply use a micro spray, a nanospray, in fact, or nanospheres. Now, can this be used in industry at a low cost? No, not yet. This is relatively expensive. Well, antimicrobial treatment is really a niche in the market. Is there going to be a huge future for this? I imagine there will be. Well, there's a good deal of potential and interest, but there are barriers currently in terms of cost and performance. Silder is a company that's been working on R&D for this for 20 years. They have lots of oxygen absorbers, films and bags, and they haven't been able to roll out the antibacterial products yet because of performance issues, not cost. Now, Gilles LENON, you're the chair of the Paper Technical Center and director of TECHPAP, and you're using paper and paper filaments to prepare active packages. Well, we're trying to solve a paradox. Packaging is a product which technically is complex and which is generally purchased because of its eye appeal. And developed countries are trying to reduce the quantity. Developing countries want more, and consumers often choose products which are most attractively packaged, whereas the overall aim is to reduce packages. So the idea is to increase the lifetime of packaged products, but as soon as consumers buy the product, they want to get rid of the packaging as swiftly as possible. We think that paper is the best material for this. It's bio-sourced, it's biodegradable, and it's printable and readily recycled. So because of this, we can use the packaging to protect the product, to inform consumers regarding expiry dates, or to provide legal information. We can also use to sell the product and differentiate from the competition, and it can also be used to convey the values and image of the brand and content. Now, because of all of this, paper and cardboard packaging will evolve. Moving forward, it will be a future product, a future trend in the future world Internet of Things. So this is a commodity, and what we want to do is to see how it will meet new consumer expectations, including the Internet of Things. You know, you're saying a lot of interesting things. You said that we deconstruct cellulose fiber in order to use micro fiber in order to create paper which is easier and provides easier to use and has greater potentialities. No, the first stage was to want paper to interact with the environment. So we started with printed electronics, or electronic printing. What we wanted was an electronic printed circuit on the outside in order to communicate with the environment. There were a number of stages. First, we came up with a special conducting ink, Next, we developed low-cost RFID tags, just a few cents per tag. The idea is to print the circuit and to have the transcoder connected with the antenna, so it's wireless. And we moved even further. This is the most recent development. This is multi-level printed circuits, printed on ordinary presses, not in a clean room. And here we can have pretty simple electronic functions, the way you would do it in standard electronics. So you have a printed circuit that's on the paper, yes, and it's printed roll to roll, continuous roll off the press, and we can use it to print something with capacitors, resistors, and we have conducting inks, resistant inks, and so what does it conduct? Does it conduct electricity? Okay, we activate a circuit like this, you need an energy source. And today we decided that we would use the energy from your smartphone. The printed circuit itself has no energy source. We'll capture the energy from your smartphone to activate the circuit and provide a response. This helps to fight counterfeits. So if you have a display which would change its color when you approach it with your smartphone to say whether it's true or a fake. And so the problem now is reproducibility of this. You say so you're active with the external world. This is really interesting. This is an RFID tag. Okay, I'm going to show you. Okay, you show it to the camera. Here we. Okay, just leave it in front of you and the camera will pick it up. So the antenna is printed and the tag is a decal. It was just placed over the printed antenna, and you can use your smartphone to query the tag and read some of the information on the printed package. And this can also be done invisibly inside or in a fold in the package. So this can be done without anyone seeing this. I think we can zoom into your hand. Okay, so here we can see it better. So this is paper, which is pretty thin. You can do it on cardboard. You can do it on any type of medium. It's printed. And this is for traceability and for spotting counterfeits, so for logistics. So for a pallet with over 1,000 objects, you can identify each and every item on each and every article, and it's only a matter of cents. And this has been patented. It was patented 2 or 3 years ago. And now we're rolling it out. We've already had our industrial pilot programs, and it works. Now, all of this led us to look at what we're going to be doing with paper and card going forward. So we're going to seek inspiration in Mother Nature. We want to see what nature knows best and what nature does best in order to try to develop our materials in a better way. So you said you use microfibers of cellulose to do things. Now, what types of properties do you want to provide for your paper? Well, we want to be more resistant. We can reduce weight by 30%. Okay, so we also have a better barrier. We can have barriers to water, gas, and CO2. When are we going to have something which is half as heavy as other things? Okay, we can do it with sparkling water. We did it as a prototype, and now we're rolling out the project in an industrial scale. As you know, in France, we are the European leader in molded cellulose. Now, people simply think that that's only the egg box. And, you have the recesses for eggs. But now we can have one piece molded cellulose bottles, which can hold water, air. You could even And we've developed the technology over the past 10 years, and we had our world first in Korea with chromatogenesis. So it's like Gore-Tex, but we do it with paper. It's breathable and it's a water barrier. So after doing that, we saw that we were able to add additional treatments to have all the types of barriers you need to meet food processing requirements. Okay, that's the opposite of an active package. This is a passive package. Well, we see active packaging in printed circuit boards on paper. Okay, that's pretty smart, says the journalist. Well, unfortunately, regulations prevent us from moving forward, and we haven't really explored the future possibilities with our packages, because obviously you can't have any migration from the packaging into food. Now, there are wonderful things being done in basic research. We could discuss it for ages, but in industrial terms, the problem is the rule and law on packaging, which prevents us from doing this. Linda MONBORREN, do you agree on this? We have a veritable fireworks of innovation. Well, yes, RFID is on the printed circuit boards. This is active and intelligent. And then you have the printed part in the packaging, which could be active. Well, this isn't fully banned by the regulations, but the rules for migration are extremely severe, and that makes things very hard to roll out.
Now, let me compare smart packagings with active packagings. Now, let's move on to smart packaging. How can you define smart? They provide information to the user. It's a category of connected packagings or smart packagings, you know, like RFID packages. Now, Hervé, OLLIEN, you're head of the Home Appliances Division at Samsung Electronics. I mean, you're inspirational for you. Of course, there's the dream of the engineer and the actuality of consumers. Yes, the market reality between customer acceptance and ready to accept and complexity it may add. For an industrialist, technologies are ready, but we will put out soon in the coming weeks a connected fridge, which we're going to market. It's a first generation of refrigerator. It's been the first one was designed 10 years ago. It will come to the market the first time. As you can see here, in a great kitchen, you can see here on the screen, it's not my kitchen, but it's a great kitchen. Why the first generation? Because we had a lot of generations before. We had code bar readers on the fridge, on the product. I'm a consumer. I'm scanning my product. When I put it in the fridge, you scan it to tell the fridge that I'm going to consume it. It must be. It can also be scanned in the trash can. And by definition, an overpack of yogurt is when you scan your 12 yogurt pack. Do you know how many cups are still remaining? But you gotta, get a scale to weigh the product. In real life, it does not really work. If you summarize, smart packaging doesn't really is something you dig if you're pragmatic. There's no database on food first. It's impossible today as industrialists, home appliances producers, to get a database of all the food products sold in the world. Even in France, it's impossible. First problem. Second problem, today, if you're talking about now products, the only element is the barcode. There's no sell by date on a barcode. Why didn't you think about putting a sell by date on the barcode? Linda, we thought about it. There's a bridge between printed technologies and RFID containing all information which may be connected to a fridge. putting the use-by date on the barcode would be an opportunity. It's not complicated, but today it's not yet done. So it's a headache, and yeah, well, for manufacturers, yes, well, by 2020, you said 100% of our products at Samsung must be connected by 2020. It is the case for all the smartphones and tablets. Personally, we're all connected, but our homes are, have remained in the Stone Age. You've got like the issues of interoperability, and that's a problem because every brand has its own information systems. Every brand is defending its system. LG, Sony, Samsung, there might be not one system, but one or two systems to date. There's no interoperability among systems. That's why the connected home is a dream. This product, to go back to this, listening to consumers, they said first that all my products in my fridge are not sensitive products. Ketchup, tube, mustard, it has no use-by date. Depending how many hamburgers you eat, you got some products in your fridge which are sensitive, and I want to be informed when the use-by date is coming soon. You take a snapshot of the content on your iPhone. When you close your fridge, you do a selfie of the fridge content. It's shown on the screen and you've got small tags on the screen, and you drag and drop the tag on the food, and based on the numbers of days remaining, you drop the tab on the food by tapping on a keyboard. You should not enter the use-by date. No, you enter the numbers of days remaining. So you enter the number of days, you drag and drop, and automatically he will or should be warned on his smartphone when the product is no longer edible. So it's a kind of collaborative mode, yes, indeed. Now, your fridge, can it be connected to other sources of data? Of course, it can beyond food management. We will incorporate a lot of new services, which they are not possible with a conventional fridge. In my recipe application embedded in my fridge, I can do a recipe. I will transfer the list of ingredients to the list of groceries I want to buy. We're developing applications with partners, with like food stores, recipes. It's a sort of repurposed connectivity. Exactly. Basically, digital means if it does simplify the life of consumers. If it's too complicated, adding time, we drop it. Let's be pragmatic and simple. There is a startup which is not present here because they apologized. They cannot delegate somebody here, so they apologize. But there is betting on the connectivity of trash cans. The Eugene trash can is connected and makes it possible to sort the trash or the waste in the trash can. They have been selected to attend a convention in Los Angeles. Okay, anyway, quite simple. It was a 41-second video. Let me summarize it. We're using the barcode of the product, recognized by the trash can, which tells whether it should be put in the yellow or black trash can. That's how you can sort the waste. In Samsung Electronics, Hervé, OLLIEN, you're not betting on the connected object as such. You're betting on the content and connectivity of the content with the consumers. Not stupid. It's a pragmatic approach to, again, reading or understanding what the consumer is ready to accept. a lot of stuff will come down the pike, but now, today, it's a pragmatic approach on our part. Mr. Adji, what about you? We're explaining basically there's a lot of limitations or obstacles. We got a lot of projects around paper, packaging paper. That's great, and we know that there will be applications out there. We have an industrialist here telling us, watch out, don't do anything because we're listening to consumers. Well, you've got technologies out there, RFID, barcode, what have you, for reading time temperature indicators, but not giving information on the packaged product, only giving information on what's put on the pack. There's another category of indicators yes, giving us information on the product itself. Like on fish, when the fish, is releasing ammonia, it's giving you problems. Let's go back to food. It could be of interest to you because basically you're taking photographs of the photo if you can recognize the change of color of packagings. Obviously, this kind of application on new packages will, of course, be very interesting for us because it will make the information more relevant. Increasing the quality of information is great, is of interest to us, provided it is simple to use for the consumer. You're a researcher, you're working at a simplification. We're working on a simple concept on the change in colors. Now, for ammonia is a base. You can tell ammonia is coming out of the degradation of what kind of food? Fish, meat, poultry, ammonia, other gases are released when the fish starts to stink. Or it could be ethylene, H2S, eggs, ethylene is the ripening of fruit. If it goes beyond, it is not edible well. Anyway, so you may develop detectors or sensors of molecules which will give us information due to a change of color or through a phenomenon called resonance, or plasma resonance. The particle size will change, it will give you a different color. Can you detect diseases? Well, that's for gas. I'm talking about gases which are released and present in the food environment, which are due to the deterioration of the quality. When gases are released, you cannot consume the food any longer. If it's a blue color, for example, a yellow color, blue is okay, yellow is bad. You got a limitation, or the product is no longer edible. Linda, well, today, let's talk about food again. Now, Linda, we have vacuum-packed food to preserve food longer. Do you have a solution to replace vacuum package by removing CO2 oxygen from the food, which will be less costly than the vacuum-packed technologies? When you talk about replacement technology, you've got to have to modify the whole production chain. Initially, it won't be less costly. Next, you've got to think about whether vacuum-packed food does resolve the problem in prepared food. The degradation occurs not on the outside, but on the inside of the food stuff. So that's why researchers like antimicrobial packages. We have no solution. I don't know whether that's why you're enthusiastic, because you're researching, that's your job. There's a lot of publications or journals. There's a lot of publications on this, and antimicrobial packaging would be a solution, could be a solution to replace by other gases. It's quite depending on the food considered. If you want to package strawberries, you might have CO2 release systems or oxygen absorbers, and you might have the opposite for other foodstuffs. So basically, technologies will adapt to the sensitivity of products. You got to adapt to the food considered. It is on a case-by-case basis. Gilles, LENON, to talk about connectivity with the outside world, the industrialization, marketing, when it will occur. What are we talking about? We talked about giving, anti-counterfeiting information. Well, this tag is already marketed, not yet, because we have another problem, namely extending, generalizing the RFID tags are not used extensively, but we're able to adapt this device to small series. The obstacle to RFID tag is as follows. You got to size the antenna. You got to take into account the material and the content involved to have a size antenna which is effective. It means large production runs, and you need a lot of production runs to reduce the cost tomorrow. If you're able to size the antenna by printing, you have removed the logjam. You've got to work with large retailers on this, opening up new vistas and opportunities. Great outlook. Thank you for taking part in this great debate. It's an exciting debate, but you've got obstacles out there. Industrialists need to streamline the systems. Let's continue on ALL4PACK TV. Let's meet in 10 minutes for a focus on how to enhance your brand through the right stickers or adhesive tags.